Hey folks, want to jump on here and shoot a quick solo podcast today. This one's going to be on the company called Wayve. I saw their profile via LinkedIn and this business has captivated me this week. I'm looking into it a bit more. That said, let's chat about it. So Wayve is a UK-based artificial intelligence company developing autonomous driving technology. Unlike many traditional self-driving companies, Wayve focuses on end-to-end deep learning, so vehicles learn to drive more like humans. Key facts: founded in 2017, headquarters London, UK, founders Alex Kendall, Amir Saha, field autonomous vehicles / AI driving systems. What makes Wayve different? Most autonomous driving companies rely heavily on HD maps, LiDAR sensors, and rule-based software. Wayve instead uses a vision-based AI approach. Cameras as primary sensors, similar to human vision, a neural network trained from real driving data. The system learns driving behavior rather than following hard-coded rules. This is often described as, quote, embodied AI for driving, end quote. Technology approach: Wayve trains large neural networks that learn from millions of miles of driving data, simulation environments, reinforcement learning. The AI processes camera input and outputs, steering, braking, acceleration in a single neural network model. Major milestones: 2021 demonstrated AI driving in London without HD maps. 2023 to 2024 large funding rounds from investors including Microsoft, Nvidia. 2024 partnership with Uber to integrate autonomous tech into ride-hailing fleets. Why the industry watches Wayve, or Wayve, WAYVE, is considered one of the leading companies pushing AI-first autonomous driving, competing conceptually with companies like Tesla, vision-based autonomy, and Waymo, sensor-heavy robo-taxi approach. In simple terms, Wayve is trying, to build a self-driving AI that learns to drive like a human rather than being programmed with rules. And here's a clear comparison of the three major approaches to self-driving used by Wayve, Tesla, and Waymo. Three different paths to self-driving AI. Number one, Wayve end-to-end AI learning. The core idea: train one big model AI that learns driving directly from experience. How it works, we already talked about this. Uses mostly cameras, a single neural net. We won't get into it too much. Tesla, vision plus neural networks. Tesla system is somewhat similar to Wayve, but more modular. It uses sensors, cameras only, no LiDAR. Radar previously used but mostly removed. System design: Tesla splits the system into parts. Number one, perception AI, detects cars, lanes, pedestrians. Won't get into too much. Number three, Waymo, sensor plus mapping approach. Waymo uses a very different philosophy. Sensors, LiDAR, radar, cameras, HD maps. How it works: number one, map the city in centimeter level detail. Number two, use LiDAR to detect objects precisely. Number three, follow rule-based planning algorithms. Advantages: extremely accurate perception, already running driverless robo-taxis. Limitations: expensive hardware, hard to scale into every city. We'll get into industry belief right now. Waymo, safest but expensive. Tesla, biggest real-world data. Wayve, most AI-first research approach. Many experts think the long-term winner will be AI systems that learn like Wayve / Tesla. We'll go to gemini.google.com in a sec. Why some researchers think Wayve could be a, quote, ChatGPT moment, end quote, for self-driving. The comparison comes from how large AI models change natural language. Systems like ChatGPT and the models behind it showed that one large model trained on massive data can outperform many hard-crafted systems. Wayve is trying to apply the same philosophy to driving. Number one, large quote foundational or foundation models, end quote, for driving. Wayve is developing what it calls embodied AI for a driving foundation model. I won't get into too much. Number two, the scaling hypothesis. AI research increasingly shows that performance improves when you scale model size, training data, compute power. The idea transformed language AI. OpenAI, Google, Anthropic. Wayve is betting it will also transform robotics and driving. Major industry or major investors supporting this idea include Microsoft, Nvidia, SoftBank. It could solve the quote long tail end quote problem. Self-driving cars fail because of rare edge cases, weird road layouts, unusual pedestrian behavior, construction zones, unexpected weather. Traditional systems try to write rules for every situation. Wayve's approach, learn from massive real-world examples, generalize to new scenarios. This is similar to how large language models handle unexpected questions. Number four, hardware could become much cheaper. Most robotaxis today, like those from Waymo, require LiDAR sensors, expensive sensor stacks, detailed HQ maps. Wayve aims to use mainly cameras, neural networks, minimal mapping. If successful, autonomy could run on ordinary vehicles. Number five, integration with ride hailing. Wayve is working with Uber. The idea is that once the AI becomes reliable, it could power autonomous ride-hailing fleets globally. Why experts are excited? If Wayve proves that foundation models can learn driving, it could dramatically reduce development costs, allow autonomy to scale worldwide, bring self-driving cars much sooner. That's why some researchers describe it as the, or quote, the ChatGPT moment for robotics, end quote. Interesting side note, Wayve recently raised one of the largest AI funding rounds in European history, approximately 1 billion plus. Which we may get into now. In 2024, Wayve raised over $1 billion in funding, presuming USD, one of the largest AI rounds ever for a European startup. Major investors include SoftBank, Microsoft, Nvidia. 1 billion plus USD in AUD. For those in Australia, it would be 1.43 if you round up AUD. That's 1.4 billion. Dollars. Let's get back. Major investors include SoftBank, Microsoft, Nvidia. Investors poured money into Wayve because many believe it could become a foundational AI platform for robotics and autonomous driving. Below are three main reasons, which we already discussed just briefly. The quote foundational model for driving, end quote vision. Wayve isn't just building a self-driving feature, it's trying to build a general AI model that can help drive anywhere. The goal, train a huge neural network, feed it massive amounts of driving video, allow it to generalize across cities and countries. This mirrors how large language models learn language. Investors believe that if it works, Wayve could become the quote open AI of autonomous driving, end quote. Number two, huge market opportunity. Autonomous driving is considered one of the largest future AI markets. Potential industries include robotaxis, trucking, delivery vehicles, personal cars, logistics automation. Analysts estimate the autonomous mobility market could reach trillions of dollars globally. That would be USD, probably similar, presuming AUD. We'll wait and see, but definitely I think that's in USD. Even capturing a small share could make Wayve extremely valuable. Number three, partnerships with major tech companies. Wayve attracted investment because of its strategic partnerships. Examples, Microsoft provides cloud and AI infrastructure through Azure, or Azure bracket, Azure end bracket, which will stop the brackets. Stop saying Nvidia provides GPU hardware for training models, collaboration with Uber for potential autonomous ride-hailing. These partnerships signal industry confidence, a different approach from competitors. Many autonomous companies rely on LiDAR sensors, detailed HD maps, rule-based software. Examples include Waymo, Cruise, Wayve's approach, camera-first vision, end-to-end neural networks, minimal reliance on maps. If it works, the technology could be cheaper and easier to scale globally. Europe wants a global AI champion. Europe has fewer large AI companies compared with the US and China. Wayve is seen as a potential European AI champion, especially in robotics and mobility. That strategic importance helped attract massive funding. In short, investors are betting that Wayve could build the core AI system that powers autonomous vehicles worldwide, which would be an extremely valuable platform. Again, we'll get into, we're just on 10 minutes. Why some experts think Wayve could become one of the most important robotics companies by 2030. We've kind of talked about this, but let's just get into it. Many AI researchers believe that Wayve isn't just building self-driving cars. It may be building a general AI system for machines that could move in the real world. If that works, it could transform several industries. Number one, driving is one of the hardest real-world AI problems. Urban driving requires AI to handle pedestrians, cyclists, unpredictable drivers, complex intersections, weather conditions, construction zones. That means the AI must learn real-world reasoning and decision-making. If a model can drive safely in chaotic cities, researchers believe the same architecture could power many types of robots. Number two, Wayve is building, quote, embodied AI, end quote. Wayve calls its approach embodied intelligence. Embodied AI means AI learns by interacting with the physical world, not just reading data. Examples, and feel free to go back to episode 13, which went over artificial intelligence, just a very general, brief episode. So feel free to go back and have a listen, and there's some other ones that you can go check out, but that comes to mind. Examples, driving vehicles, warehouse robots, delivery robots, industrial machines. This is different from language models like those behind ChatGPT, which mainly work with text. Number three, a platform model for robotics. The long-term vision is a foundation model for physical machines. Instead of writing custom software for each robot, one large AI model could control cars, delivery robots, drones, warehouse machines. This idea is similar to how foundation models power many apps today. Number four, the data advantage. Driving produces massive amounts of real-world data. Vehicles can collect video of roads, traffic behavior, environmental conditions, driver actions. That data set becomes extremely valuable for training AI. Companies like Tesla, Waymo also rely heavily on driving data, but Wayve's architecture focuses on learning general behavior rather than specific maps or rules. 5, integration with global mobility networks. Wayve is working with Uber. If autonomous driving becomes reliable, Wayve's AI could run global robo-taxi fleets. That would create a huge network of vehicles, constantly generating training data, improving the AI even faster. Why investors are excited. If Wayve succeeds, it could become a core AI platform for autonomous vehicles, a foundation model for robotics, a key technology supplier to global transportation networks. That's why investors like SoftBank, Microsoft, and NVIDIA invested heavily. One fascinating twist, some AI researchers believe the race for self-driving cars is actually a race to build the world's first general-purpose physical AI. Fascinating. Coming up on 12 minutes, I think, 13 minutes, so we'll try to get through this. Why some engineers think Wayve could beat Tesla in self-driving. Both companies rely heavily on AI and cameras, but their strategies are different. Some researchers believe Wayve's architecture may scale better long term. Number one, end-to-end AI versus modular AI. Wayve, one big driving model. Wayve trains a single neural network that goes directly from camera input to driving actions. Example, video frames to neural network to steering / braking / acceleration. The AI learns behavior directly from data. Advantages: simpler system architecture, easier to improve with scaling data and compute, potentially better generalization. This is similar to how large language models replace many small NLP systems. Tesla, many AI systems combined. Tesla's system is more modular. It includes separate components. Number one, perception, detect objects. Number two, prediction, anticipate motion. Number three, planning, choose route. Number four, control, drive the car. Advantages: easier to debug, more control over decisions, but critics say this architecture can become very complex over time. Number two, generalization. generalization to new cities. One major challenge for self-driving is driving somewhere the system has never seen before. Wayve's idea: train a model that understands driving behavior, not specific roads. Example: driving in London works in Tokyo, works in Sydney. Tesla system can also generalize, but some researchers argue Wayve's behavior learning approach might adapt faster. Number 3, training philosophy. Wayve emphasizes reinforcement learning, large-scale simulation, real-world driving examples. Tesla focuses more on supervised learning from fleet data, rule-guided training. Both approaches to work, but Wayve's method aims to produce more flexible driving intelligence. Number 4, hardware neutrality. Wayve is designing its AI so it can run on many different vehicle platforms, not just one brand. Tesla system only runs on Tesla vehicles. That means Wayve could potentially sell software to automakers, delivery fleets, robotaxi operators, logistics companies. Why investors like this model? Investors include, we already talked about this, Microsoft, Nvidia, SoftBank believe Wayve might become a global AI platform similar to how systems power many devices. In simple terms, Tesla is building the best self-driving system for Tesla cars. Wayve is trying to build a general AI driver that can power any vehicle anywhere. Interesting fact, some AI researchers think the real winner in autonomy will be whoever builds the best, quote, physical world foundation model, end quote. That's why companies like Wayve are attracting huge attention. I think we're around the 15-minute mark. We haven't even got to Gemini.google.com. I've just been fascinated. Well, it's detailed. We're 16 minutes. Maybe we'll go slightly over. Why most autonomous car startups fail, but Wayve survived. Over the past decade, dozens of self-driving startups collapsed or shut down. The field turned out to be far harder than investors expect, yet Wayve kept growing while others struggled. Here are the main reasons. Many startups choose extremely expensive hardware. Early self-driving companies built cars with huge sensor stacks, multiple LiDAR sensors, radar systems, high-end cameras, powerful onboard computers. This made vehicles extremely expensive. Some robotaxi prototypes cost, presuming USD, $200K to $300K per vehicle. Many startups ran, which would be slightly hot, 200K. That'd be $284,000, give or take. And that'd be, I'm presuming, 384. $300,000 equals 426,318 Australian dollars. So 200K USD to 300K USD per vehicle. Many startups ran out of money before achieving scale. Wayve took a different path. Camera first approach, fewer sensors, lower hardware costs, the HD map problem. Many companies relied on ultra detailed HD maps. Example workflow: number 1, map every street in a city in centimeter detail. Number 2, update maps constantly. Number 3, train the car to drive only within those mapped areas. Companies like Waymo still use this approach successfully for robotaxis, but startups discovered a problem. Scaling this globally is very slow and expensive. Wayve system tries to drive without depending heavily on maps, learning behavior instead. Number 3, the quote edge case explosion, end quote. Driving has millions of rare situations called edge cases. Examples: construction, detours, emergency vehicles, unusual road layouts, unpredictable pedestrians. We already mentioned this. Many systems relied on rules and handcrafted software, but engineers discovered something: there are too many edge cases to manually program. Wayve's strategy is to let AI learn behavior from massive data rather than coding every scenario. Number 4, massive computing costs. Training autonomous driving AI requires huge computing power. Companies need enormous data sets, simulation environments, powerful GPUs. That's why partnerships with companies like, which is the fourth time, Nvidia, Microsoft, became crucial. Many smaller startups simply could not afford the compute infrastructure. We already talked about Nvidia on the podcast. Feel free to go back and listen. Not Microsoft yet, but maybe in the future. Number 5, investor patience ran out. Autonomous driving was once predicted to arrive by 2020, but development proved slower. Major companies shut down projects, including Argo AI, backed by Ford and VW, Volkswagen, presuming. VW is Volkswagen, I'm pretty sure. Cruise scaling back operations. Wayve survived because investors believe its AI-first approach could scale faster in the long term. Why Wayve is still standing: it focused on AI learning instead of rule-based systems, cheaper hardware, scalable architecture, partnerships with major tech companies. This combination convinced investors that Wayve still has a real chance to solve autonomy. One last interesting point: many AI researchers believe the first company to solve, we've already talked about this, real self-driving may accidentally create, we didn't talk about this. Many AI researchers believe the first company to solve real self-driving may accidentally create the first true, quote, robot brain, end quote. Driving forces AI to understand the physical world, not just text. Wow. Fascinating. We'll do our best to keep this under 30, or do my best. The global AI race in autonomous driving, US, China versus Europe. Autonomous driving isn't just about cars anymore. Many experts believe it's a strategic AI race between regions. The technologies developed for self-driving vehicles can power robots, drones, logistics systems, and smart cities. Below is how 3 major regions compare: United States software and AI leadership. The US currently leads in AI research and autonomous software. Key companies: Waymo, Tesla, Cruise. Strengths: world-leading AI talent, strong venture capital ecosystem, huge compute infrastructure, GPUs, cloud. Major AI infrastructure companies include NVIDIA, Microsoft, which is the 5th time. The US advantage is software innovation and AI models. China, large-scale deployment. China is extremely strong in real-world deployment. Major companies: Baidu, Apollo, autonomous driving, Poly.ai, AutoX. Advantages: government support, smart city infrastructure, large test zones for robotaxis. Some Chinese cities already run large robotaxi fleets. Europe, AI research and safety engineering. Europe focuses on AI research and safety engineering. Key companies: Wayve, Mobileye. Europe's strength: strong robotics research, automotive engineering expertise, strict safety regulations. Wayve represents Europe's push to build a major AI company competing globally. Why autonomous driving matters for AI. Solving self-driving requires the AI to understand, which you went over this before, physics, motion prediction, human behavior, real-world perception. That means the company that solves it may also unlock general purpose robotics AI. This could impact warehouse robots, delivery drones, humanoid robots, smart transportation systems. In simple terms, US, best AI software and compute. China, fast deployment and scale. Europe, strong research and engineering. The winner of autonomous driving could become a global platform for robotics and physical AI. Interesting twist: some AI researchers believe that the first true, quote, physical world AI, end quote, might emerge from self-driving car research before humanoid robots do. Let's go over to Gemini. Wayve is a London-based leader in embodied AI for autonomous driving. Unlike traditional self-driving companies that rely on high-definition HD maps, rigid hand-coding rules, Wayve uses a, quote, AV2.0, end quote, approach, a mapless end-to-end deep learning system that, quote, learns, end quote, to drive similarly to a human. As of early 2026, the company has transitioned from a research powerhouse to a commercial heavyweight. Key milestones in 2026 updates: massive Series D funding in February 2026. Wayve closed a $1.2 billion USD, presuming Series D round, part of a larger $1.5 billion capital commitment dollars valuing USD the company at $8.6 billion USD. $1.2 billion in AUD, Australian dollar, is 1.7 AUD. So 1.2 billion is 1.7 AUD, and 8.6 billion US dollars is around 12.2 billion Australian dollars. Fascinating. High-profile investors, we talked about this: NVIDIA, Microsoft, Uber, SoftBank, and major automakers like Nissan, Mercedes-Benz, and Stellantis. Uber partnership and London robo-taxis. Wayve is launching commercial robo-taxis in London in 2026 in collaboration with Uber. Wayve provides the quote AI driver end quote software while Uber manages the fleet operations. They plan to scale this to over 10 global markets. Consumer vehicle rollout 2027. Starting in 2027, consumers will be able to buy passenger vehicles initially with Nissan equipped with Wayve's AI, offering quote hands-off end quote level 2 plus autonomy, quote zero shot end quote scalability, demonstrating the power of their mapless approach. Wayve successfully completed a quote AI 500 end quote roadshow, driving autonomously in 500 cities across Europe, North America, and Japan without any prior city-specific fine-tuning. The technology embodied AI, which we discussed. Wayve's core advantage is their ability to generalize to new environments without needing expensive infrastructure. Feature Wayve AV 2.0, traditional AV, AV 1.0, mapping in the Wayve 2.0 or the AV 2.0. Mapless uses real-time vision. The traditional AV 1.0 requires extensive HD 3D maps, logic, end-to-end AI neural networks with Wayve. Traditional AV, hand-coded rules, and quote if-then end quote logic. Hardware, sensor agnostic, mostly cameras with Wayve. AV 2.0. Traditional AV 1.0, heavily reliant on LiDAR/radar. Scale with Wayve AV 2.0, global, works in any new city. Traditional AV 1.0, geofenced, city-by-city rollout. Core models, GAIA2, a generative, quote, world model, end quote, that creates photorealistic driving videos to simulate rare, quote, edge cases, end quote, like a child running into the street in a storm, allowing the AI to train safety in simulation. Lingo 1, a version language action model that allows the AI to, quote, explain, end quote, its driving decisions in plain English, making the, quote, black box, end quote, of AI more transparent for regulators and users. Whew, covered a lot today. This is fascinating. We're coming up on 30 minutes. We'll go over to Claude.ai. Maybe we'll bring in Perplexity again in the future. Wayve is a British autonomous driving company that has become one of the more interesting players in the self-driving space. Here's a quick overview. What they do, founded in 2017 by Cambridge PhD researchers Amir Sa and Alex Kendall. Wayve takes an end-to-end deep learning approach. Eschewing detailed 3D maps and hand-coded rules in favor of a self-learning, quote, AI driver, end quote, that learns from camera data and driving experience. What makes them different? Their approach contrasts with competitors who build rules-based systems integrating complex sensor arrays. Wayve wanted a more generalized, flexible approach that could be scaled quickly and deployed by different car makers. That's by Microsoft EMEA. I believe that there's a citation or just a link. Crucially, their Mapless AI, I think it's just a link. Wikipedia is the first one talking about their background. Crucially, their Mapless AI solution facilitates effortless adaptation to any environment, eliminating the need for HD maps, simplifying global deployment, and significantly lower cost. This is on Wayve. A link. Funding and backers. Wayve has raised over, this says 1.3 billion, so I presume it's 1 billion plus from investors, including SoftBank, Microsoft, and NVIDIA. Key partnership, Wayve, which sat on ChatGPT, and Uber announced plans to develop and launch, we already talked about this, public road trials of level 4 fully autonomous vehicles in London, the largest market where Uber has announced an intention to pilot autonomous vehicles. Nissan and Wayve are aiming to bring advanced AI driver assistance to mass production vehicles worldwide. Latest tech. In December 2025, Wayve launched GAIA 3, a 15 billion parameter generative world model for evaluating autonomous driving AI, built on 10x more data than its predecessor. Early studies show it closely mirrors real-world driving results and has reduced synthetic test rejection rates fivefold. Ambition: as of 2025, Wayve envisions its AI driver being applicable across a range from level 2 driver assistance like Nissan's ProPilot all the way to level 4 robotaxis, and delivery vehicles with partners like Uber and Ocado. For those who don't know, I believe Ocado is based in London as well. I don't think they're outside of London. Yes, Ocado delivers extensively outside of London, operates a nationwide service across most of the UK. Okay, excuse me. They operate in the UK, not just in London. We're just over 30, we're on 30 minutes now. They use several large customer fulfillment centres, CFCs, including sites in Erith, Dordon, Bicester and Bristol to serve areas beyond the capital. I think that's it. Let's just go over this in a little conclusion. One big thing about Wayve. The simple, most important idea behind Wayve is using one large AI model that learns to drive directly from experience instead of programming driving rules. This is called end-to-end driving AI. How traditional self-driving works, most autonomous systems break driving into many modules. Number 1, detect objects. Number 2, track movement. Number 3, predict behavior. Number 4, plan route. Number 5, control steering/brakes. Companies like Waymo and many early startups use this structure. This makes the system very complex with thousands of rules. Wayve's idea, Wayve tries something closer to how humans learn to drive. Instead of writing rules like if pedestrian detected, slow down, the system learns from millions of driving examples. The pipeline becomes camera, video, neural network, steering/braking/acceleration. One big AI model handles everything. Why this is a big deal? This approach follows the same scaling principle that made modern AI powerful. Large models trained on massive data, transformed language, e.g. ChatGPT, image recognition, speech AI. Wayve is trying to apply the same idea to physical world intelligence. If it works, and if Wayve succeeds, the same type of model could control cars, delivery robots, warehouse machines, drones. This is why investors like me, we talked about the 6th time, maybe plus, SoftBank, Microsoft, and Nvidia invested billions. In one sentence, Wayve is betting that one giant AI model trained on driving data can learn to drive anywhere without needing maps, rules, or expensive sensors. That's it. I think that this covers most of it. I've just been fascinated by this week in particular. I think that's it. I think we'll call it there. There's one more thing that I found, but yeah, I think that's it. There's another title that says the quote crazy end quote part of Wayve's strategy most people miss. The surprising part about Wayve is that driving may just be the training ground, not the final product. Many AI researchers think Wayve is this like the appendix. Many AI researchers think Wayve is actually building something much bigger, a general AI system that can control machines in the physical world. Number 1, cars are just the first robot. A self-driving car is basically a robot with wheels. To drive safely, the AI must learn how objects move, how humans behave, how to predict the future, how to plan safe actions. These skills are general robotic skills, not just driving skills, so the driving model becomes a training environment for physical intelligence. We already talked about this. The data flywheel. Number 2, driving generates huge amounts of real-world data. We talked about this. A foundation model for the physical world. Why big tech is paying attention. Companies like Microsoft, Nvidia, SoftBank are investing because robotics plus AI can become a multi-trillion-dollar industry. If one company builds the core AI brain for machines, it could power entire industries. The big hidden idea, Wayve, might not just be building self-driving cars, it may be building the first scalable AI brain for real-world machines. Driving is simply the hardest training environment to develop. One more fascinating thing, many AI researchers think the company that solves self-driving will actually create the first practical general robotics AI. That's why the race between companies like Wayve, Tesla, and Waymo is so closely watched. I think that's it. Let's go back to the one big thing. We've covered a lot today. The data flywheel as well, we didn't go over too much, but let's try to find it, the one big thing. The single most important idea behind Wayve is using one large AI model that learns to drive directly from experience instead of programming driving rules. This is called end-to-end driving AI. I think that's it. In one sentence, Wayve is betting that one giant AI model trained on driving data can learn to drive anywhere without needing maps, rules, or expensive sensors. Thanks for listening, folks. Have a great rest of your day.